are going to talk about radical functions today. So a radical function is a root function. We will be looking at both the square root function and the cube root function, and there will be a variable, x usually, underneath the radical sign. You can also write a root function, like this would be the square root function, as a fractional exponent, or the cubed root would be x to the 1/3 power. So these are exponents. So that's another way to write that you're using a root function. It might be easier sometimes to type that or to write it that way than the other way. This function, it's an interesting one because if you did the square root of x and at the same time negative square root of x, it would look very much like a parabola turned on its side. So it turns out that y equals x squared, if you took the inverse of that, it would look like this. However, this would not be a function because it would not pass the vertical line test. But if you just look at a piece of it, which is what we're doing, then you have the square root function, which is a function. And here's some examples of replacing x with different values of what you chose to be x, and then simplifying and finding what you get for y, and you'll see that it graphs a nice kind of slowly increasing curve. This one has an endpoint, this function. That's unusual for our functions to have an endpoint, and if it's just the parent square root of function, just square root of x, the endpoint is 0, 0. And that is because we cannot put a negative number inside of a radical and get a real number out. We could get an imaginary number, but we're not going to work with imaginary numbers for this. So our domain for this would only be x is greater than or equal to 0. Now that can be adjusted if your function has been shifted left or right, then your domain will also be shifted left or right. For example, the domain in this one, you can see it right here, is x is greater than or equal to -3. In our parent function up here, the range would also be y is greater than or equal to 0, because that's the biggest number you can get out of this. Is if you let x be 0, then your answer would be that y is equal to 0. And the range did not change in this function because it did not move up or down, it just was shifted left. Yeah, shifted left. This is what the cubed root function looks like. This is the cubed root function over here. I put the cubic function here too. This would just be like y equals x to the 3rd power, and you can see how it looks very similar but has been rotated, and it's been kind of flipped over, and that's how you can see that these two are the inverse of each other. The domain of the cube root function is all real numbers, because in this one x is going to continue to get more and more negative and more positive on the other end, so it's just all real numbers. And the range, even though it increases slowly, it will increase when you are looking at the right side, and on the left side it will decrease. So the range is also all real numbers. A little bit more about cube root functions. Here's some other characteristics of them. This is the parent function of the cube root function. That one will have a 0, or the x-intercept will be there, and this one also has the y-intercept there. Of course, if your cube root function has been transformed, it will have a different x and y-intercept, but it will have an x and y-intercept. And this one has an increasing interval always, because even though it kind of goes up here, it's still increasing. So it's always increasing. It's never decreasing, this function. And the end behavior we talked about will go to infinity as x it gets bigger and bigger and bigger, and it'll go to negative infinity as x gets smaller and smaller and smaller. Here's some more notes. Some of a lot of these we've already talked about. The radical functions do not have asymptotes. Neither the cube root or the square root one will. Remember that the square root function has an endpoint, so the end behavior on a square root function will be different than a cube root function. And the cube root function may be symmetric about its point of inflection, but the square root function will not have symmetry. And let's look again at this cube root function. I forgot to talk about the concave up and concave down. This part over here is concave up, hold some water in that, and this part over here is concave down. So the point of inflection is where it switches from one to the other, and it may be symmetric about that point, whatever that point may be on your graph. Square root functions will not have an inflection point. They'll be either concave up or concave down. And a square root function will have a max or min. It'll be that endpoint, but cube root functions will not have a max or a min. So you're going to answer some questions. This one is about this cube root function. And then there's one for a square root function. And then you're going to graph two of them. You can graph these on your graphing calculator and then sketch the graph here, or you can graph them using Desmos. If you are using Desmos, you have to go to the keyboard, the Desmos keyboard, and then in Desmos there's another menu for more functions, and that's where you'll find the ability to make the cube grid. So I'll show you that, and we'll graph this one here. Okay, so here in Desmos is the, oh, I forgot to get the keyboard function. Okay, so now I have Desmos set up so that you can see the keyboard, which is down here, or the keypad I guess they call it. So to graph f of x equals the cubed root, there, f of x equals, now I need the cubed root, so I'm going to go to this keypad, and then over here to functions menu, and then to miscellaneous, and here it is. This is the nth root. So I get to call it the cubed root or the fourth root or whatever I want, and I needed x minus 2 for this graph. So then you can see the graph from there. And remember, in Desmos you can get a link to this graph, or you can take a screenshot. I like the screenshot method because you can you can then see it while you're answering the questions about it. So I'm going to just go ahead and take a snip of it. If you're using Windows tool, there's a snipping function, and then I'm going to go back to the worksheet and paste this onto the worksheet. And I don't need this one anymore. Alright, so let me get back to my first questions. I think so I pasted it after the domain apparently. That's okay. The domain of this would be all real numbers, and the range would also be all real numbers. Because x can be anything and y will be anything given that x can be anything. Then it says for which x values is the graph concave down? Okay, where is it concave down? Let's see. We have concave down over here, right? So it looks like from x greater than or equal to 2, probably to infinity. So I'm going to say that x, it's probably just greater than 2. 2 might be the inflection point there. For which x values is the graph concave up? Well, that is over on this side. This is concave up over here. So that would be x is less than 2. And then, of course, we're asked to approximate the inflection point. I'm not sure why that moved. And the approximate inflection point looks like right about here. Now, we have to use calculus to find the exact point, but it's going to be very close to that or exactly that. Alright, x-intercept, where does it cross the x-axis point? Well, in this one, it crosses the x-axis right at that point of inflection. So the x-intercept is 2. There is a y-intercept in this one. I didn't actually ask you for it, but we could approximate the y-intercept. It looks like it's at about -1.25. Is there symmetry? I think there's symmetry about the I spelled that wrong. About the inflection point. Because we can see that we could rotate it about that point. And then everything's moving along with my graph or my fingers here. End behavior. What's happening as x approaches infinity? So as x gets bigger and bigger, what's happening to the graph? Well, the graph is also going to approach infinity. And what happens as x gets smaller and smaller and smaller? The graph, or the y value, is also going to approach negative infinity. So you have a few of those problems to do, and you can let me know if you have any questions. Thank you very much and have a wonderful day.